Hey smart people, Joe here. Stay tuned for a special announcement after the video. So I used to have this shirt. I know at least one of you was watching back in 2013. Hey Kyle. Now for the rest of you, you're probably wondering the same thing as me. What is up with the hair? What this shirt means is that the microbes in and on our bodies outnumber our own cells. The most common figure is by 10 to 1. Except that's not true. It's a scientific urban legend. Yet this continues to be shared and recited as fact. I mean, I'm guilty of it too. My old video is called Your Mainly Microbe, and it is literally centered around this erroneous factoid. It turns out that urban legends like this are surprisingly common even in science, and how they begin and why they persist can teach us a lot about how science works and when it doesn't. At some point, the 10 to 1 bacterial to human cell ratio became common knowledge. Now, common knowledge is information that the average educated person in some group, the general public, scientists, whoever, accepts as reliable without having to look it up. Like how we all know that water freezes at 0 degrees Celsius. We all know that, right? Now, somewhere along the line, people stopped asking where this common knowledge came from. Well, there are countless facts in science that have become common knowledge. I mean, if research papers cited an original source for every single fact they presented, it would be an absolute mess. I mean, say you wrote a paper about synthesizing some new chemical. Do you have to cite a paper that proves chemicals are arrangements of different atoms? Or, okay, then do you have to cite something that proves atoms exist? Maybe Einstein's 1905 paper on Brownian motion, or do you have to go back to John Dalton in the early 1800s? You can see that things get pretty ridiculous pretty fast. But sometimes things that aren't true become common knowledge, or they're corrected later, but the new information fails to replace the old idea. Here's an example. I wouldn't be surprised if at some point in your life you probably heard that spinach was a particularly excellent source of iron. I mean, I certainly remember being taught that. I can't even remember where. You can probably guess where I'm going with this. It's not true. In 1981, a biologist named Terry Hamblin studied historical science papers and realized that the iron content in spinach was misreported thanks to a misplaced decimal point way back in the early 1900s. Except he didn't cite a source for the misplaced decimal point story either. And it turns out that that's a myth too. Turns out the earliest old school measures of iron in spinach were way too high and wrong, but because of contamination, not a misplaced decimal point. It's science. Details matter. Spinach actually does contain large amounts of iron, as much as red meat in some cases, but it also contains compounds that make the iron it does have harder for us to absorb. So it's not an exceptionally great source of iron. And I'm willing to bet at some point in your life you've taken vitamin C to help cure or prevent a cold. Yeah, that's not true either. That myth traces to legendary scientist Linus Pauling. In 1966, Pauling was convinced by a random dude named Irwin Stone that taking large doses of vitamin C would help him live longer. And Pauling started taking doses equivalent to hundreds of glasses of orange juice every day, and wrote books and articles claiming that the colds he had suffered from his whole life no longer occurred. Even though Linus Pauling won 2 solo Nobel Prizes in his life, dozens of studies have since proven he was wrong about vitamin C. It doesn't significantly affect colds, and the only disease it definitively prevents is scurvy. Yet somehow the cold myth still continues today. Or maybe you've heard that you lose most body heat through your head. Well, that urban legend goes back to one military study in the 1950s where people were left out in the cold with no hats on. I mean, you're gonna lose most of your body heat through your head if that's all that's exposed. Today, scientists know the amount of body heat you lose depends on the total surface area exposed. But parents everywhere are still making sure you don't leave home without a hat. You also don't need to drink 8 glasses of water a day. That urban legend probably goes back to one set of dietary recommendations for water intake from 1945. Except many people who cited that number ignored the part where it said most people get the majority of water they need from food. It's important to stay hydrated, but 8 glasses, I mean, like, what size of glasses even? And one of the most famous is that sugar causes hyperactivity in children. This one seems totally logical, but more than a dozen randomized controlled trials have failed to detect different behavior between kids given large doses of sugar and kids who weren't. That's right, the cake is actually a lie. Turns out when parents even think their children have been given a drink containing sugar, even if it's actually sugar-free, they tend to think their kids are being hyperactive. This particular urban legend traces its origin back to a California allergy doctor, Benjamin Feingold, in 1973, who with little to no evidence recommended removing artificial colors and flavors from the diets of hyperactive children. And I guess people were like, why not sugar too? I mean, kids are just kids, and they're gonna go nuts sometimes. Things we consider common knowledge can be based on bad information, and despite the amazing power of science to correct its own mistakes and uncover better and better knowledge over time, that good knowledge doesn't always spread out and replace the bad knowledge. So how do these scientific urban legends continue to persist? More scientific journals exist today than ever before, and we're doing more science today than ever before. Most of that science is peer-reviewed, but peer-reviewed doesn't always mean something is true. If one false citation makes it into the system, it can set up a domino effect as other people cite that very bad fact instead of verifying the original. The solution? Well, for you out there in the general public at least, wherever you can, even if you think something is common knowledge, try to learn where it came from. You might be surprised by what you find. But that is easier said than done, because most published science today isn't freely available, at least not legally.